Hello everyone. Today we're going to cover everything a backend partner developer needs to know in 2025 to feel as comfortable as possible. But before we get into all of that, you can find all the cheat sheets, consultations, interview tips, support, and other advanced materials in my Telegram channel linked in the description. Just go to the description, and the very first link will be to my Telegram channel. Now, let's start with the first thing, which is Python. What does that mean? It means you need to know the new versions. Python is expanding, updating, and new versions are coming out. Python 3.11, 3.12, there are a lot of new things, so keeping up with Python is a must right now. Next is Python common libs. These are the standard libraries that we have. Some standard libraries get removed or deprecated in new versions, or something new gets added, but overall, you need to know them and be able to work with them. Next is async.io. In general, asynchronicity. Asynchronicity is spreading everywhere, so being able to work with it, understanding how it works, and knowing which libraries are available, this is absolutely essential right now. Multi-threading. Why multi-threading? Because in Python 3.12, a new flag was introduced that disables the GIL and gives us the ability to work with multi-threading. But that's not the main point. Overall, this is about multiprocessing, working with multiple processes, threads, and all that. So it's also important to know, to be able to work with it, to understand what it looks like and what it actually is. Next, SQL. I have advanced material on SQL, which you can check out on my Telegram channel, but nowadays you can't get by without it. Of course, working with databases goes without saying. Regarding frameworks, when it comes to frameworks, next we have an intermediary like ASGI WSGI, which allows us to route our traffic from a specific user, for example, who initiates a request, to the chosen framework and work with it. If we talk about ASGI, then this is a synchronous approach. This is fast API. If it's WSGI, then that's Django or Flask. Although for Django and Flask, I think there's even just ISGI now. All of this is being introduced. So ISGI is currently the main one, while WSGI is more about legacy. It's just good to know and be able to work with it because older technologies still exist and some things need to be maintained. Next is working with networks. It's an important and necessary thing. You can't do without it. How HTTP works, what versions exist, what response statuses there are, what REST is, what a request consists of, and so on. This all relates simply to HTTP and working with requests. Next, we have something a bit more exotic, RPC, which is used for working with multiple services. For example, when working in microservices, gRPC allows us to do this in a more or less convenient way, though it has its own shortcomings, but still. GraphQL also allows you to organize data delivery processes in a fairly convenient way, but it imposes other limitations in terms of caching. But that's not the point. You can look into that later as well. That's why understanding how networking works, so we organize the interaction between our backend and our user is essential. Next up is databases. It won't come as a surprise that databases are important and you need to know them. But to feel as comfortable as possible, we have a division here. I didn't draw arrows here, but let's assume they were already there. Let's save it. Bam! What is this? Working with a database. You can use any database, but at the very least, here are 3 DBMSs that we have, which you should be able to work with and know how to interact with. These are PostgreSQL and MongoDB. But before you continue watching, I recommend you check the description because there you'll find links to advanced material. If you're having any issues with getting a job or if you want to improve your skills, get help, consultations, or interview preparation, it's all there because we cover everything from start to finish. I also have my own Telegram channel where I write extensively about all of this. Cheat sheets, help, consultations, all of that is there as well. So check out the description, take a look at the advanced material, and subscribe to the Telegram channel. So you can work with this trio and find out what it's all about. The fact that we have PostgreSQL means it's a relational approach, which is pretty cool. You should know at least one of them. And Mongo is non-relational, so you can work with that as well. We also have columnar databases and others like graph databases. So there are many types, but at the very least, knowing the basics PostgreSQL and Mongo are essential. You really can't get by without them. Next, when it comes to scaling databases, there's sharding, replication, and approaches to distributing the load in terms of writing and reading, like read-only replication, master-master. Master-slave, these concepts shouldn't raise any questions for you. Optimization, that is how we will optimize not just the queries, but the overall work with the database. Here we're talking about indexes, that is how and where we will set them, what types of indexes exist, how we will structure queries, and how we will inspect each of these queries in terms of how much time we spend on them. That's why this is important and necessary. Next is the theory of microservices, that is what they are, how to build them, and what they consist of. How to create real microservices, not a distributed monolith. Here we specifically break things down into microservices themselves. The CQRS approach, that is, separating commands and queries is also an interesting topic worth looking into, as well as event sourcing. All of this in general can also be applied to a monolith, but in the context of microservices, it generates quite a lot of interest. That's why it would be worthwhile to work with these approaches. Next, message brokers. Naturally, when we work with microservices, this is just theory. But when we move up to the next level of working with microservices, we need to exchange messages. We can exchange messages both in a synchronous format, when we make a request and receive a response, and in an asynchronous format. This includes Kafka and RabbitMQ. When working with Kafka and RabbitMQ, it's important to understand that you need to know how not to lose a message. That's why I didn't write one important thing here because of this. The outbox pattern. Let me write it down here. What is it? But first, let's get back to message brokers, Kafka, RabbitMQ. Actually, it might seem like a pretty straightforward story, like they're basically the same thing, but that's not quite true. Kafka and RabbitMQ promote completely different approaches to working with queues. Kafka is a log where we write something, and from which our microservice reads. RabbitMQ, on the other hand, is a queue where we load our values, and RabbitMQ simply spits out those values to the microservice that needs them. It's important to know and understand how to set up delivery guarantees. So we have 3 delivery guarantees. Exactly once, when we need to deliver a message exactly one time, this is the outbox pattern, which needs to be implemented together. Then there is at least once and at most once, meaning either exactly once, at least once, or at most once. So these delivery guarantees allow us not to lose our messages, and if something happens, we will remain within the same context. But in some cases, we might lose a message. It all depends on your specifics, on your work. So what is the outbox pattern? When we work with our messages Kafka, RabbitMQ naturally, our message can slip away somewhere, but why would we want that to happen? We can take our message that we want to send and put it into some kind of storage. This could be a database, maybe an outbox table in the DB. Once it's in there, our broker will read it from that location. It reads it. Aha, great. Okay, let's pass it along. It passes our message to another, what's it called, microservice. The microservice responded to this message, and in the outbox, we can update our value. Or we can immediately, in our other microservice, if we're using a pattern where the outbox table connects all our microservices, then we can also change the flag to indicate that the message has been delivered, something like that. That's why the theory and how to work with all of this is important and necessary. You can't get anywhere without it. There are posts about all of this on Telegram. Next is caching, working with cache. Caching our values Redis is one option, but there are other alternatives as well. But the point is to cache so that we don't have to compute everything or fetch from the database every time, but just access the cache. This process is fairly simple. We just have decorators that allow us to do this. Next is observability, monitoring, logging, tracing. Logging is a big topic. There are different libraries for tracing. There are also various libraries for that. But for monitoring, we mainly have 2 tools, Prometheus and Grafana. Prometheus is used to collect our data. Basically, we attach some kind of handler to our backend service, which allows us to simply extract data from it. We just pull them along, we take the data, fetch it, and move on. Grafana, on the other hand, visualizes all this in a clear tabular format, giving us the ability to view everything in a convenient, attractive way without any issues. That's why the concepts of observability, monitoring, logging, and tracing are important. It's important to know that tracing is, roughly speaking, when we track each request, the interactions in the code, and how much time each one takes, while logging is simply recording information in a clear format. There are many different libraries, and not just libraries, but also services, so it's really up to your personal preference. But monitoring is the main thing, simply because we monitor each of our services and display the information in a clear, visually appealing format. Next, web servers, this means Nginx. It's basically a must-have. You can't go anywhere without it. You need to know how Nginx works and be able to configure it yourself. Without this, you shouldn't even think about having any kind of comfortable experience in backend development. CI, CD. Here, the point is that you need to be able to set up CI, CD, and pipelines yourself. It's not, not super complicated, at least in general terms. Of course, you're not a DevOps engineer. Obviously, you don't have to be a genius, but knowing how to set it up and understanding how CI, CD works and interacts is important and necessary. You can't get by without it. And here, GitHub and GitLab actions are simple. It's literally just one file where you write the configuration, upload the SSH token from your service or server, and running it there is not difficult. Jenkins is a bit of a big monster. It would also be worth working with it just to know what it looks like. In other words, where and what we need to configure so that our changes are picked up. Jenkins would check and see that a commit has occurred. Great. Let's run our linters, for example, and maybe some other checks. What else do we have? Let's run the build and deploy it to our server, to the staging environment, to our staging contour. Next is working with infrastructure. Again, you're not a DevOps engineer, but you need to know how to work with all of this. You need to know how to interact with the environment, with the infrastructure, and not get lost. That's why Kubernetes is now essential for backend. There's no way around it. You need to know the basic concepts, and sometimes you might even need to write your own YAML file and run it. And to interact with it in a learning format, there's Minikube. But Minikube has its own shortcomings, so you can use K3s. K3s is a simplified way to work with Kubernetes that operates across multiple nodes. With Minikube, it runs on a single node. There's just one node there. Again, this imposes certain limitations because that's exactly what a Kubernetes cluster is about. Its main purpose is to create a cluster out of several servers. And our application is distributed across multiple servers so that, if necessary, we can balance the load. It's the same thing with Docker, specifically with Docker Swarm. I didn't write Docker Swarm here, but you need to know it as well. Docker Swarm is a must-have. Some people say it's dead, but at the very least, to fully understand how to work with a cluster of our nodes, Docker Swarm is a really straightforward thing. It's as simple as it gets. You don't need to invent anything new. The configuration is written in the Docker compose file, and that's great. Docker, as I said, is basically the main thing you absolutely need to know, really know inside and out. Kubernetes is something you can configure, interact with in the dashboard, check out and Lens, take a look at. But Docker is the main thing. You can't go anywhere without it, just like Docker Compose in general. Working with Linux or scripts shouldn't raise any questions for you. It would be worthwhile to get some hands-on experience with Linux. There are different distributions, Ubuntu, Debian, CentOS. It would be good to at least try working with one of them. So that's how it is. Moving on, Solid. There are different principles. We have principles like Solid, Kiss, Tirai, Yagni, Grasp. It would be worth knowing at least one of these. Solid is the main one, really. Everything else is secondary. That is when it comes to architecture, to working with architecture. Solid, Kiss, dry these are straightforward concepts. So here it's actually not so much about Solid, but rather about the approaches and principles that you need to know and work with. Design patterns. I actually had a video for front end, just like this one, with a design pattern algorithm in the last sections. Why is all of this being established? In reality, design patterns aren't anything drastically radical. For example, builder, singleton, prototype, proxy, decorator, you'll already be familiar with these. One way or another, you'll know about them and interact with them. Design patterns are needed, roughly speaking, just to check the box that you worked with them. You don't need to know all the design patterns, but it would be good to be able to write out and at least explain how at least 3 from each approach work. In other words, you don't need to know exactly when to write, say, a facade pattern. Basically, the only thing you need is to know and understand how all of this works. In the process, you can always Google things, look them up, and so on. And the main thing is algorithms. Well, not the main thing, but the last one. Why are algorithms in last place? Well, that's generally how it is here. It's not because you'll be studying a huge number of algorithmic problems. No, but from the point of view that nowadays there is a strong desire to see algorithms and interact with them, but it's not like that's the case everywhere. Again, you can get a job without algorithms. But the point is that here we are talking about feeling as comfortable as possible. Maximum comfort means, for example, that you can get a job at some big tech company. And to get a job at any big tech company in any market, you need algorithms. Without algorithms, you simply won't be able to. And it's not just about knowing how to calculate algorithm complexity or write a tree or traverse a graph. No, it's more about working with lead code, code words, that kind of thing. Everyone will be able to solve the easy level. If you can't solve the easy level, then you have big problems. You should at least try to solve the medium level. So solve the medium level problems and stop there. That's basically. There's really no point in reaching the hard level at all. So being able to solve the medium level is generally enough to handle these algorithmic tasks. They can all be different. So it's not guaranteed that the exact problem you've solved will come up in the interview, but at the very least, you'll know the general approach to solving them. So that's about it. That's basically all for now. We've looked at a table that's not too big, but not too small either, of what you need to know. There are a lot of topics here that are worth diving into, so it would make sense to go through it from the bottom up and gradually fill in any gaps you might have. So that's about it. That's basically all for now. Today we went over the roadmap for backend development in Python, so subscribe to the channel, leave a like, and let's stay in touch.